Imagine drifting through the silence of space. Beneath you lies not a planet, but a frozen moon just over 500 kilometers, or 311 miles across. Its surface is fractured, with geysers erupting from the cracks, hurling icy plumes hundreds of kilometers into space. Originating from a hidden ocean, these plumes beg the question of life within. These are some of the moons that rarely make headlines. Enceladus, erupting water ice into space. Triton, a captured world. Hyperion, tumbling unpredictably. Miranda, stitched together from fragments of catastrophe. Rhea, perhaps encircled by rings. Our solar system is far more than 8 planets circling the sun. As of March 2025, it contains a collection of 891 confirmed moons, with Saturn alone hosting 274 of them. Many of these moons are small and inactive, little more than rubble. Yet some are alive with activity, hosting oceans beneath their ice, geysers venting into space, chaotic rotations, and surfaces reshaped by ancient violence. Now, let's turn to Enceladus. This moon is deceptively small, only about 504 kilometers, or 313 miles in diameter. Near its south pole, 4 immense fissures, commonly referred to as tiger stripes, slice across the crust. From these fractures, geysers eject water vapor, ice grains, and gases at speeds approaching 1,440 kilometers per hour, or 895 miles per hour. The Cassini spacecraft made several close approaches to Enceladus and flew through these plumes in 2008, sampling their chemistry with the instruments available. In October 2025, Nature Astronomy published findings of organic compounds within the plumes. These were chains of carbon-based structures that may be capable of fueling microbial life. The ice around Enceladus has an average thickness of around 20 to 25 kilometers, or 12 to 16 miles. Beneath the ice shell lies a global ocean, warmed by tidal forces as Saturn's gravity pulls at the moon's interior. Enceladus has an eccentric orbit around Saturn, where its distance from the planet fluctuates. As Enceladus drifts between distances from the gas giant, gravitational forces flex the moon's interior. This constant stretching and compressing generates frictional heat. That heat prevents the ocean from freezing solid, maintaining liquid water beneath the ice. Supercomputer models released in November 2025 revealed that Enceladus's plumes lose far less mass than once believed. This discovery points to a resilient ocean, one that endures beneath the ice and resists freezing, sustained by the ceaseless pull of Saturn's gravity. The chemistry of this water includes hydrogen, silica, and phosphates, ingredients for hydrothermal vents similar to those on Earth's seafloor. Such vents are thought to be the potential birthplace of life on our planet. Oxford University researchers concluded that Enceladus's ocean could sustain microbial ecosystems. Pressure variations within the ice could create zones where conditions vary drastically between liquid, vapor, and ice. On Earth, extremophiles thrive in comparable environments, like Antarctic lakes and deep-sea vents. NASA and the European Space Agency have proposed missions to sample Enceladus's plumes directly. The possibility of detecting alien microbes within our lifetime is no longer science fiction, but an active scientific pursuit. Leaving Saturn behind, we journey outward to Neptune, where Triton awaits. This moon is 2,707 kilometers, or 1,682 miles wide, larger than Pluto. Triton orbits retrograde, moving against Neptune's rotation, the only large moon in the solar system to do so. This unusual motion reveals hints of its past. Scientists think that Triton was once a Kuiper belt object, but was captured by Neptune's gravity millions of years ago. Its surface is dominated by frozen nitrogen, with geysers that spew dark plumes of dust and gas up to 8 kilometers, or 5 miles high. Voyager 2 observed these eruptions in 1989, our only close encounter. Scientists suggest the geysers may connect to subsurface activity, perhaps even a thin ocean beneath the crust. Triton's terrain includes cryovolcanic features and regions nicknamed cantaloupe terrain for their wrinkled appearance. Unlike Earth's volcanoes, which erupt molten rock, cryovolcanoes expel water, ammonia, or methane in liquid or vapor form. On Triton, nitrogen eruptions sculpt the surface, leaving dark streaks across the icy plains. Tidal forces are gradually pulling Triton closer to Neptune. In billions of years, it will drift too close to Neptune and disintegrate, potentially forming an extensive ring system around the ice giant, similar to Saturn's. For now, Triton remains a relic of the solar system's chaotic past. While the likelihood of life is lower than on Enceladus, who knows how resilient life may be on other worlds. Triton's captured status provides vital clues about how planetary systems can evolve and interact. Returning once more to Saturn, we encounter Hyperion, a chaotic oddity. Stretching only about 360 kilometers, or 224 miles at its longest point, it tumbles unpredictably due to gravitational interactions with the much larger moon Titan and Saturn. Its porous surface is riddled with craters so deep it has a sponge-like appearance. Hyperion's chaotic spin is partly due to gravitational resonance with Titan. This resonance occurs when two bodies exert regular, periodic gravitational influences on each other, locking their motions into complex patterns. In Hyperion's case, the resonance destabilizes its rotation, creating perpetual unpredictability. Hyperion's low density, composed mostly of ice, mixed with dark organic dust, causes impacts to punch holes deep into the surface, rather than leaving typical craters. Its erratic rotation also means there is no consistent day-night cycle, only endless flipping. Now, let us swing outward to Uranus, the ice giant tilted on its side. Orbiting it is Miranda, the smallest of its 5 major moons, measuring about 472 kilometers, or 293 miles across. Its surface is a jumbled mosaic of towering cliffs, plunging valleys, and twisted ridges. Some cliffs rise up to 20 kilometers, or 12 miles high, dwarfing Earth's tallest mountains. Scientists theorize that Miranda may have been shattered by a massive impact billions of years ago and later reassembled by gravity. Or that tidal heating or impacts reshaped its surface unevenly, with certain areas thawing and refreezing later. Miranda shows how small moons can still exhibit dramatic features. Though no ocean has been confirmed, Miranda is still another fascinating piece of our solar system. Finally, we return to Saturn once more, to Rhea. measuring roughly 1,528 kilometers, or 948 miles across. Rhea is composed of rock and water ice. In 2008, it was suggested that faint rings of debris may be surrounding it, possibly formed by micrometeor impacts. The existence of these rings remains debated, but if confirmed, Rhea would be the only moon known to possess its own ring system. Rhea's surface is heavily cratered, showing ancient bombardments. The moon remains tidally locked to Saturn, meaning it always shows the same side to the planet. While 2025 yielded no major discoveries, Rhea continues to intrigue scientists with hints of subsurface water layers beneath its quiet exterior. Together, these moons illustrate the diversity and unpredictability of our solar system. Enceladus, with its ocean rich in organics. Triton, the captured outsider. Hyperion, tumbling through space. Miranda, pieced together from chaos. Rhea, perhaps encircled by rings. These moons all contribute to our understanding of planetary science, and each one serves as a new place to study geology, chemistry, and orbital mechanics. To understand them is to better understand the forces that shaped our solar system and perhaps the conditions that allow life to emerge. They remind us that life may not be confined to planets. With missions like Europa Kuiper already underway and Dragonfly bound for Titan in 2028, the coming decades may reveal whether these moons could harbor life. What are your thoughts on these moons and the many others in our solar system? Do you think one of them may actually contain life? I'd love to hear your thoughts in the comments below. If you enjoyed this video and would like to show your support, feel free to hit like and share it with other curious minds. It helps a lot, and I truly appreciate it. If you'd like to learn more about our solar system and beyond, subscribe and hit the bell icon so you don't miss our next journey through the cosmos. Thank you so much for watching. Until next time, my friends, take care and be well.